We're going to walk through an example where we find the volume of a solid of revolution that's obtained by rotating the region bounded by the given curves about the y-axis. In this problem, we are going to be using cylindrical shells. The curve that we're given is y is equal to 2x squared minus x cubed, and y is equal to 0. Just to make this easier, I went ahead and graphed both of these curves, and you can see the region enclosed by these curves in green. You may have previously studied disks and washers, and what sets this problem apart is you can't use disks and washers because in this region, the curve on the left is the same as the curve on the right. So cylindrical shells are the best to use. We're going to be revolving this curve about the y-axis, and the cross-sectional area is cylindrical shells. The thickness of each shell is dx, so we are going to be integrating with respect to x, which means the first thing that we need to do is find the x value for the points of intersection. To do that, we just have to set the curves equal to each other. So we're going to say 2x squared minus x cubed is equal to 0. We can factor out an x squared, and that leaves us with 2 minus x is equal to 0. And we can see then that x is equal to 0 and x is equal to 2. Let's mark these on our graph. Here we have x is equal to 0, and here we have x is equal to 2. So those are going to be our limits of integration. Now what we have to do is look up here at our formula. Our formula for the volume of the solid that we're going to get is 2 pi times the integral from a to b, that will be from 0 to 2, r times h dx. What we need to do now is find r and h. This is our radius, and this is our height. The radius is the distance from the curve to the y-axis, and that is equal to x. And then h is the distance from the x-axis to the curve, and that is equal to y. Now we can go ahead and write down our formula. Our volume is 2 pi, the integral from a to b, r times h dx. So this is 2 pi, our a is 0, and our b is 2. Our radius is x, our height is y, and we're integrating with respect to x. We now need to substitute in that y is our curve 2x squared minus x cubed. This gives us our volume is 2 pi times the integral from 0 to 2. We have x, and then we have 2x squared minus x cubed dx. Before we integrate this, let's simplify what we're going to be integrating. This is 2x cubed minus x to the fourth times dx. Now we can go ahead and integrate this. The integral of 2x cubed is 2x to the fourth over 4. And then we subtract off x to the fifth over 5. And we're integrating this from x is 0 to x is equal to 2. Now let's substitute in that x is equal to 2. So we have 2 times 2 to the fourth all over 4 minus 2 to the fifth over 5, and then we subtract off 0. This gives us 2 pi. 2 to the fifth is 32. So we have 32 over 4 minus 32 over 5. Let's pull the 32 out. So this gives us 64 pi. And then we have 1/4 minus 1/5. We will get a common denominator of 20. And then we get 5 minus 4 on top. So this is 64 pi over 20. and each number is divisible by 4. So this gives us an answer of 16 pi over 5. Our volume then is equal to 16 pi over 5.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.